You are pretending to hear a story when someone across the room says your name. Every other voice is mush, but those two syllables arrive perfectly sharp. Your attention flinches before you have decided whether the voice was even real. How did one word escape an entire wall of noise? You did not consciously inspect every conversation and select the important one. Most of the room never became clear language inside your awareness. Something in the ignored sound matched a signal unusually important to you. For a moment, that signal stole control from the conversation you chose. Own name capture is one famous piece of the broader cocktail party problem, but the famous story hides a wonderfully inconvenient fact. In controlled experiments, most participants do not report hearing their name. By the end, you will know why a name can help and why it never proves someone heard you. Moray inserted each participant's name into a message they were told to ignore. It was not an alarm, threat, or explosion. It was a phrase containing the participant's own name. 4 of 12 people reported noticing it while shadowing the other message. That result became famous enough to sound universal. It was not universal then, and later experiments did not make it universal. A careful replication found name detection in about 35% of participants. A pre-registered study decades later found it in 29%. The name also left a fingerprint on the task people were trying to perform. Those who noticed it made more shadowing errors around the moment it appeared. Their attention had not simply expanded to hold two perfect conversations. When the name was noticed, performance on the chosen message briefly worsened. That changes the effect from superhearing into a trade. The name can capture attention, but it does not guarantee comprehension or even detection. If you need someone to hear you in noise, their name is not confirmation. Wait for an answer instead of assuming the signal crossed the room. To understand what the name interrupted, begin with the broader cocktail party problem. A crowded room is dozens of vibrations reaching your ears at almost the same time. Voices overlap with music, footsteps, glass, laughter, and the air conditioner. The auditory system must separate that mixture into possible sources. Location helps because the same voice reaches each ear slightly differently. Pitch, rhythm, timing, and vocal texture provide more grouping clues. Visible mouth movements can provide another clue when the speaker is in view. Those clues help competing voices behave like separate streams instead of one noise. Then, attention gives one stream priority. The chosen speaker becomes easier to follow while competing speech loses detail. This is not the same as muting every other voice completely. It is closer to raising one signal while aggressively lowering the rest. Colin Cherry built an early laboratory version of this problem in the 1950s. Participants heard competing speech and repeated one selected message aloud as it arrived. That demanding task is called shadowing. It provides an online measure of how well the listener follows the selected stream. When questioned afterward, people usually knew remarkably little about the rejected message. They could miss words that had been repeated again and again. They might notice broad physical changes without recovering the ignored conversation. Attention preserved the target while much of the rival message lost detail. Why can a name trigger that trade? The experiments establish that your own name has unusual priority. They do not establish exactly how that priority was learned. The honest mystery is why this personally relevant sound sometimes survives selection. But relevance does not mean the brain understands every ignored sentence in secret. The pre-registered study also planted semantically unexpected words in unattended speech. Those surprising words were rarely detected and did not disrupt shadowing like names did. Under those conditions, the participant's name captured attention more effectively than ordinary weirdness. Working memory adds another twist. One study linked lower working memory span to more reports of the ignored name. The pre-registered replication found the same direction but not a reliable detection difference. It did find that lower span participants made more nearby shadowing errors. The relationship is suggestive, not a settled law about attention. The original interpretation was that stronger control protects the chosen message more effectively. That interpretation fits some results but remains correlational. Detecting more background information is not automatically better or worse attention. The measured task rewards staying with the selected speaker. Modern brain recordings show that selection changes the internal representation of speech. In one study, patients heard two speakers talking at the same time. Electrodes recorded activity directly from the surface of their auditory cortex. The attended speaker emerged in the neural pattern far more clearly than the ignored one. Researchers could reconstruct important features of the voice people were following. The pattern resembled the chosen speaker more than the physical mixture entering the ears. Your cortex is not merely making a faithful recording of the room. It is building a version shaped by what you are trying to understand. That still does not create one tiny guard waiting beside a mental doorway. The combined studies show enhancement of selected speech without guaranteed erasure of everything else. Different experiments preserve different traces of the task-irrelevant stream. The word ignored therefore describes reduced priority, not a promise of zero processing. Laboratory headphones are useful because each ear can receive a perfectly controlled message. Real rooms are messier because voices share space, vision, movement, and meaning. To test that mess, researchers built a virtual cafe around their participants. A nearby character spoke while a background barista called out food orders. Some orders secretly contained the listener's name. Others contained words that made the order semantically bizarre. Brain and skin responses distinguished those probes from ordinary control words. Yet people did not reliably turn their eyes toward the background speaker. The response can stay covert. Brain and skin signals changed even when gaze did not. That does not prove participants consciously understood the background speech. It shows that task-irrelevant language can affect the nervous system without an obvious turn of the head. The border of attention is selective, flexible, and occasionally porous. Speech clarity places one tested limit on the effect. A recent experiment compared ordinary spoken names with increasingly compressed versions. Own names still slowed an unrelated visual task, but intense compression weakened that capture. Personal relevance cannot rescue a signal after too much usable speech structure disappears. The larger lesson is uncertainty, not a perfect name detector hidden in your head. Laboratory reports cluster around a minority of listeners under specific tasks. Real rooms add vision, movement, expectation, distance, and uncontrolled competing speech. The research explains a possibility, not a guaranteed reaction every time your name is spoken. You can look for the trade the next time you enter a noisy room. Choose one speaker and notice how quickly the rest become texture. If another voice captures you, check what you missed from the chosen conversation. Treat the result as an observation, not a diagnosis of your attention. The practical lesson is not that your brain hears everything. It is that attention favors selected goals while some highly relevant signals can still interfere. Your name sometimes wins, but the studies do not reduce that priority to one simple cause. The victory is brief, imperfect, and paid for with something else. So return to the party and the voice that seemed to cut through the room. The noise never opened a magical tunnel directly to your ears. Your brain briefly changed which stream deserved to become your world. And one familiar word clicked hard enough to move the entire spotlight.